Hi, I'm Marty Triola, and I'm here to talk to you today about the first topic in the book, statistical thinking. Now, because this is the very first topic in the book, I thought I would just take a minute to introduce some aspects of the course, to talk a bit about the nature of the course, before I really get into the topic of statistical thinking itself. So, first of all, this course doesn't really involve the methods of traditional mathematics courses. We're going beyond formulas. By beyond formulas, I mean that the real emphasis is not just in problem solving. It's not in algebraic manipulations. It's not in demonstrating arithmetic prowess. It's really taking results and making sense of them. Common sense is a real critical factor in this course. Also, critical thinking. We want to develop and use our critical thinking skills so that when we do get results, we can make practical sense of them. And in this course, it's been my experience that many students can succeed, even if prior math courses were very challenging. I've had mathematics students or statistics students who did not do well in prior mathematics courses. They barely met prior prerequisites. Yet in this course, they were able to get good, solid A's by working diligently and applying common sense. On the other hand, I've had even mathematics majors, excellent mathematics backgrounds, and some of them did not do that well because they took the course for granted. They didn't realize this different aspect of the course, the emphasis on critical thinking, the fact that it's not an algebraic manipulation course, it's not an arithmetic course. Also, throughout the course, you're going to be looking at an abundance of real data. This is not a course in abstract theory. Even at the end of just this one semester, you'll be able to apply some of the things you learned in a very practical way. And hopefully you're going to encounter applications that involve the field that you might really be considering as a future profession. And the methods that we use in this course are not strictly in the area of statistics. They're methods that are somewhat universal in the sense that you're going to see these methods used throughout a number of different disciplines. For example, if you're majoring in a health field, medicine, biology, you might be reading a professional journal and you might encounter an application of a hypothesis test, something that you would learn later on in the course. So the methods that we use are not strictly mathematical. They do have universal applications. So those are some of the key features of the course. Look for applying your critical thinking skills. Don't worry so much about algebraic manipulations and working with formulas and arithmetic. Also, I might mention that in this course, you have some excellent opportunities for growth. I touched upon critical thinking. We'd really like to develop critical thinking skills so that you could look at newspaper reports, journals and professional articles, and you could make sense out of them. You could try to analyze them, see flaws in some of them. Technology. We really hope to develop your technology skills. And I might just touch upon a couple of applications of technology. One would be that if your professor allows you to use any calculator whatsoever, I might recommend this Texas Instrument TI-83 Plus or TI-84 Plus calculator. This calculator is not cheap. It'll typically run $80, $90, $100, but it'll make a real difference in what you could do in the course. The calculator has built into it a number of different functions designed specifically for the introductory statistics course, and it would be a tremendous help for you. And the expense could be offset somewhat by the fact that you'd be able to resell it at the end of the semester. Although it's been my experience that students, even non-mathematics majors, students in a variety of different fields, once they became comfortable with the TI-83 or 84 plus calculator, they tended to keep it because they felt so comfortable with it. They really felt it became a great asset to them. Another recommendation that I would make for technology is StatDisk. It's a free statistics software package. It's on the CD that comes with your book. And I'm just going to do a really quick demonstration of StatDisk on the computer. So I'm going to switch over to the computer now and click on StatDisk to activate it. So you just simply have to download it to your computer. Click OK to get it started. And on the StatDisk screen, number of different menu items. Under Analysis, you have a lot of the functions we're going to do throughout the course. Under Data, you could do things like descriptive statistics, histograms, box plots, different kinds of graphs you're going to be encountering later on in the course. Under Data Sets, you could look at the book you're using and click on that. Let me go back to Data Sets. Click on the book that you're using and select a data set. For example, I'll select female health measurements, and I'll just take pulse rates. It's column 5. I'm going to click on Data. I'm going to Explore Data. I'm going to select column 5, Evaluate, and I get back the mean, median, mid-range, variance, standard deviation. These are all terms that you're going to learn about later on in the course. They're very important. Graphs, histogram, box plots, normal quantile plots. You can see by just clicking a few buttons, it becomes quite easy to get an abundance of nice features. And StatDisk is really designed to execute or analyze every major application throughout the textbook. And even if you're using another statistics software package, for example, some of you might be using Excel or Minitab, or you might be using the TI-83 or 84 Plus calculator exclusively, StatDisk would be a nice, easy check to confirm that the results are consistent and that you're doing things correctly. StatDisk is really designed to be extremely easy for you to use, and that's what the main emphasis is, and it's designed specifically for this textbook. So I really hope that you could take good advantage of StatDisk. Now, in addition to critical thinking and technology, 2 other opportunities for growth would be collaboration and presentation. Many instructors require a project in your course, and I really hope that that's the situation here, that you get involved with a project. Relative to collaboration, it would be great if you could work together with a few other students in implementing something that you might have learned in this course. And working together is really important. The number one reason why people get fired from a job is not their inability to perform the job, it's their inability to get along with others. So collaborative work is really helpful to you on a personal level. And also presentation. If you have an opportunity to do an oral presentation as part of a project, that would be an excellent activity as well. So I've talked to thousands of people that teach this introductory statistics course across the country, and I find that they're really concerned about teaching an effective statistics course, conveying the content effectively, but they're really also concerned about student growth, encouraging you to grow in ways that are so important to you as individuals and as professionals. So, and this course is an ideal vehicle for that. Now, to get back into the major topic of this first segment, statistical thinking, I want to talk about the context of the data, the source of the data, and the sampling method. You can see that these topics are really non-numerical. They don't really involve computations. They involve thinking about where the data come from, how they were collected. So I'm going to talk about each of these separately. First, relative to context of the data, let's look at this data set. We have here X values, Y values, 112, 114, and so forth. Now, by context, suppose that I tell you that these values are IQ scores of husbands and wives. Let's say that X is the husband, Y is the wife. So the husband has an IQ of 112, and his wife has an IQ of 114. This husband has an IQ of 102, his wife has an IQ of 99, and so forth. if that's the context of the data, well, I think about that and I think, well, what would I do with data of this type? What would be the issue? Well, the issue here would be, is there an association between the two? Do husbands and wives of high IQ tend to marry together? Is that the case? If so, I'd like to look for that association. In statistics, we call that a correlation. And so that indicates a particular direction of research and analysis that I might pursue. But let's suppose that they're not IQs. Let's suppose that these are weights before and after some type of weight loss program. So before the weight loss program, this person weighed 112 pounds, after 114. So they actually gained 2 pounds. This person lost 3. This person gained 4. Here, the context would send me in a totally different direction. I don't care about a correlation or an association. What I would care about is the diet really effective? And for that to be the case, the before weight should tend to be higher than the after weight. So now the data are matched, but I'm looking for a relationship where these values tend to be higher than their counterparts. A different direction of research. Part C. Suppose these are weights of randomly selected New York residents and weights of randomly selected California residents. Now they're not matched or paired. They're totally independent. And when I think about the issue of research here, I might consider whether or not Californians tend to weigh more than New Yorkers. Another totally different avenue of research. Finally, suppose that these are the jersey numbers on football players from the New York Jets. And suppose these are jersey numbers from football players on the New England Patriots. Now, if these are jersey numbers, they don't really measure or count anything. In effect, they take the place of names. It's easier to just put a number than a name. And this would indicate to me that from a viewpoint of statistics, I can't really do anything with them. So worthless from a viewpoint of statistical analysis. No real calculations would make any sense here. So the context is critically important for determining what you're going to do with the data. Source of the data. The source could have a significant impact on how we consider the data. Do we consider them to be a good data set or one that might be very suspect, one that might be very suspicious of? Here are a couple of examples. Consumers Union, they don't accept outside advertising. They conduct independent research and analyze products. And I've visited the Consumers Union test facility, and I know that they're very unbiased, very objective. And so anything that came out of that, I would feel very confident with. National Institutes of Health, a government agency, I'd feel confident with that. If it's a clinical trial sponsored by a drug company, I might be more suspicious. So you want to look at where the data are from. Were they sponsored by somebody that has a vested interest in obtaining particular results? Sampling methods, absolutely critically important. You're going to learn later on about a few different sampling methods. Here I'm only touching upon 2 of them. A voluntary response sample is basically one that is self-selected. The people that respond volunteer to respond, as opposed to being selected by the person conducting the study. A random sample, people are selected, or people or subjects or whatever is being studied are selected randomly. And that's tricky to do. It's not haphazard. You have to plan the randomness very carefully. But you should always consider the sampling method. And throughout this book, we're often going to assume that we do have a random sample. And there will be cases throughout the book where you're going to encounter applications of voluntary response samples. And you should always know that a voluntary response sample is not good from a viewpoint of statistical validity. If people themselves could decide to participate by mail, by responding to a television solicitation, by calling in voluntarily. It's been historical in the past that those with strong interest in the topic are more likely to respond. So you don't get a good representative sample. Voluntary response samples, very bad. For statistical significance now, I want to talk about two different concepts here, statistical significance and practical significance. With statistical significance, we have results that are not likely to happen by chance. Okay, the results are different enough from what you would expect to happen by chance that we say that they're statistically significant. Let me give you a real simple example here. Let's suppose I just flip a coin 100 times. Okay, and we'll look at two possibilities. In one case, I get 52 heads out of the 100 tosses. Okay, somebody might argue that 52 heads is more than 50%, so the coin favors heads. But a statistician would say, no, you could easily get 52 heads just by chance with a fair coin. So even though this is more than 50%, it's not statistically significant. On the other hand, if I got 97 heads out of 100 tosses, well, that's not likely to happen by chance. The likelihood of that happening by chance is infinitesimal. It's almost impossible. So here I would say that the result is statistically significant, and this coin favors heads. Now, a separate issue would be practical significance. You might have a result that is statistically significant, but it might not be practically significant. Let's take a quick look at an example there. We'll look at the Atkins weight loss program. Okay. Here we have 40 subjects. After 1 year on the Atkins weight loss program, these 40 subjects had an average weight loss, a mean weight loss of 2.1 pounds. Now, by using our methods of statistics that you're going to learn about later on, there is statistical significance. They're not likely to lose an average of 2.1 pounds by chance. Yet, just think about this. This is where our critical thinking comes in. If you've spent a year on a weight loss program and you've lost 2.1 pounds, that's not very much. Doesn't seem to be worth the effort. So here we would say that even though there's practical significance, there is not, rather, even though there is statistical significance, there is not practical significance. Yes, statistical significance. No, it's not practically significant. So, in conclusion then, for this section, for statistical thinking, we're going to be thinking about topics like the context of the data, where did the data come from, the sampling method, how were the data collected, really extremely important. Are the results statistically significant? And if so, do they then have practical significance? And you can see that none of these things really involve formulas or calculations. They really involve common sense, critical thinking, skills we'd really like to develop throughout this course. So that concludes this segment. Good luck with your homework exercises, and we'll see you next time. Thank you.